Good morning, afternoon, and evening. It's Wednesday, May 6th, and on behalf of everyone at Simulations Plus, welcome to today's webinar, Deployment of ADMET Predictor as a Solution for In-Silico Modeling of ADMET Properties. Presenting today will be Drs. Michael Lawless, Eric Jamois, and moderating our Q&A session is Dr. David Miller. An opportunity to ask questions will follow today's presentations. You may send in your written question at any time using the questions pane on your control panel. For optimal video and audio connection, we highly recommend you close any other additional web or streaming applications that may affect your internet bandwidth. This call is being recorded for playback on www.simulations-plus.com. Now, before we get started today, we have a quick poll question. Are aspects relating to deploying in-silico ADMET solutions relevant to your research environment? If you'll please take a couple of seconds to go ahead and answer now. Just a few more seconds here. Wonderful. So it looks like everyone's in the right place today. Now it's my pleasure to introduce today's first speaker. Dr. Eric Jamois is the Director of Business Development at Simulations Plus, with a background in organic chemistry and experience in computational sciences. He has spent the last 10 years working with medicinal chemistry CROs. He joined Simulations Plus in February of 2019 and is responsible for the ADMET Predictor business. Eric, I turn it over to you.
Well, thank you, Arlene, for this kind introduction, and thank you for joining us in this webinar focused on the deployment of ADMET Predictor as a solution for in-silico modeling of ADMET properties. So here is a quick outline of what we will be covering today. I'm going to give you a brief overview of the ADMET Predictor suite, and then we will get into license and deployment options for the software with standalone licenses, how that compares to network setups, and other deployment options at your disposal. We will see how you can check in and check out licenses with a graphical user interface and switch back and forth between full and viewer mode. We will speak about the chemistry module. We will also spend some time in the analysis and visualization tools, which are open use within the software, in the sense that they don't actually consume any licenses. We'll cover MedChem Designer. We will also speak about command line options and how you can run the software without the graphical user interface. And then we will touch on to workflow tools like KNIME and Pipeline Pilot, for example, how you can configure nodes, and give you a few examples on the kind of workflows that you can run. So here is a quick overview of the ADMET Predictor suite. There are currently 7 modules which are actively licensed in ADMET Predictor. The chemistry module is actually provided to all of our users, has some interesting cheminformatics related functionality, and there's also a quote-unquote core, which again refers to the open use tools within the software for the analysis of data and other common tasks. One of the things I should mention is that, so there are indeed 6 modules here which can be licensed individually. There are no prerequisites or dependencies between modules, which means that they can be licensed in any combination. And so let me describe briefly what these modules are. There is the physicochemical and biopharmaceutical module, which contains a set of models relating to pKa, lipophilicity, like a SLOC-P, permeability, solubility, and currently a number of transporter modules. There is a metabolism module, which is focused on metabolism by CYP, UGTs, and aldehyde oxidase, with a number of regression and classification models. So there are substrate, non-substrate models, which are classification type, and then there are site of metabolism modules for CYPs and UGTs as well. There's also kinetic models, inhibition models, and clearance models. So it's a pretty significant suite of models within this metabolism module. Toxicity contains a number of tox-related models, like the HERG model for cardiotoxicity, liver toxicity, acute tox, carcinogenicity, skin sensitization, and some environmental toxicity models. There is also a MedChem Studio module, which, as the name suggests, contains a large number of medicinal chemistry-oriented functionalities, such as clustering, so you can cluster compounds into families, generate R group tables, enumerate some analogs, and then perform some sub-SCR type work in terms of activity cliff analysis, for example. There is also a module dedicated to building your own models, that is ADMET Modeler, and within this module you can either build your own models and also expand the existing models that we have within the software using what we call a delta model approach. And last but not least, this is HTPK. This is a high throughput PK module, which provides the ability to do simulations based estimates of pharmacokinetic parameters, and also calculation of optimal dose for human or rat. So these are mechanistic types of calculations. So let me give you a brief overview of the deployment options for the software. So essentially, we support 3 different kinds of licenses: standalone, network, and cloud. The standalone options are licenses which are issued for running on a single computer. It can be used by a single person, of course, be the owner of that machine, but it can also be shared to log in by multiple people. So it can be an open access computer. So we're not licensing on the basis of a named user or a seat. And you could also access that desktop remotely if you desire to do so. The network setup is somewhat different. In this case, ADMET Predictor is installed on individual machines, so it would be installed on these 4 machines that are depicted here, and then you would have a central license server which is contacted when the software is started or when certain licenses are requested by users. And this particular setup allows you to have certain customized settings for each one of the users. And lastly, we also offer cloud computing options through Amazon Web Services. So again, there's three different ways. A few more aspects that are pretty important about the standalone versus network licenses. Again, the standalone typically it's used on a single machine. It can run multiple sessions, and there's a possible upgrade path between the standalone and the network licenses, and actually that upgrade path is free. We do not differentiate between standalone and network as far as pricing of the technology is concerned. So, and again, if you have a network license, then so we use Flexera as the licensing software, and essentially the software can be used with any computer that can communicate with the license server. One thing which is really important to point out that, because I believe that's pretty unique to our software, is that if, say, these first two users have exhausted the set of licenses that are available, and users 3 or 4 want to access the software, then the software will still start. It will actually open in what we call viewer mode. So as we will see later, the parts that are actively licensed are the actual calculations on the models, but as far as the analysis tools, anybody can use them, even if other people have exhausted the set of actively licensed features. So here's a quick snapshot of a typical scenario that you might encounter when deploying native ADMET Predictor. And you have access to a pretty significant panel of visualization and analysis tools. We'll actually get a demonstration of these capabilities later. There are already tools within the software to allow you to manage your licenses. And this is actually under help. You can view your license status in terms of the total licenses that you have and what's available for you to potentially check out. And in this panel, you can actually go back and forth between the full mode and the limited viewer mode. This is actually a snapshot of the next release of the software, termed APX for ADMET Predictor 10. It will have additional capabilities in terms of viewing who is using what. So if you have a network license, you'll be able to see who is using which features. So if you see that someone is holding a large number of licensed items, you can jot them a quick text and say, are you still using this? Let me know when you're done, because I'd like to use these licenses when that time comes. So that's that. So in terms of deploying ADMET Predictor, there are many advantages actually to deploying the software in its native interface. And as I mentioned earlier, one of the big incentives or advantages in doing so is the fact that there are no licenses that are consumed in the visualization and data analysis aspect. If you want to be very conservative with your licenses, you can actually set up the software to start in viewer mode so that nothing will actually be consumed when you start it. And you will know at this point which tools are at your disposal. Again, the licenses are consumed only in the active calculations. In some instances, they are used when you perform a calculation and retained, because the software doesn't know whether you'll be performing more tasks afterwards or not. So it's working on the conservative side, assuming that you will need to continue. But in some other instances, features can be used and returned to the pool immediately after the task has been performed. And I think Michael will show us some examples of that. If you want to return your consumed licenses to the pool, at any time, you can revert to viewer mode. You can do this either manually through the box I showed in the previous slide, convert to viewer mode, or you can set that up in the preferences to happen automatically after a certain set time of inactivity. So if you've got your session open with a bunch of licenses checked out, and for whatever reason you left your office for several hours, those licenses would be returned into the pool. A few words about the chemistry module. Again, this is a module that is provided free of charge for all of our clients. It has a number of chemoinformatics or chemistry-oriented functionality. For example, you can remove common and smallest fragments when applied to a structure. So if you have, say, hydrochloride salts of a molecule, it will automatically strip salts, for example, or if you want to neutralize certain functional groups by adding or removing hydrogen atoms, you can do that automatically. You can also standardize certain functional groups and again convert them to a standard form, like example here being the nitro groups. You can also standardize tautomers and convert them to a fixed representation, which may be the preferred way that you want to see them. So other deployment options for the software include command line. We have many of our users who actually use command line in a very productive way. So I think Michael will also give us an example of that. And this is probably what you would pass on commands to from, say, a web interface, for instance, if you wanted to do that. You also have the ability to access the software from alternate front ends. So we actually have several of our users, customers who are using a Spotfire as a front end. So behind each one of these points would be a molecule, for example, and you would be able to compute on the fly whatever set of properties or pre-compute properties, depending on the size of the data set, pre-compute properties for these molecules. Command line access is available, of course, for Windows, which is our primary platform, but also for Linux. And I should mention that on Linux, there's no user interface, so Linux is command line only. You can also run the software through workflow platforms. As I mentioned earlier, it can be run through Pipeline Pilot or through KNIME. So I'll say a few words about some recent R&D efforts which have been going on within our walls. We've actually put a significant amount of effort towards the parallelization of our code, which has a direct impact on the productivity of our customers. The software was already pretty fast, but we actually brought it into a new dimension here. Essentially, all of the model calculations are multi-threaded or support multi-threaded calculations now for all the models and descriptors, including even the HTPK properties. So I did run a few tests on my machines a couple weeks ago and proceeded to compute properties for about 10,000 or so compounds from the enamine diversity set. On the previous version of the software, that ran in 3 minutes and 30 seconds, so that's about 50 compounds per second. In the new version, APX, that's runs slightly under a minute. So we have close to a 4-fold improvement in terms of performance. What is most pertinent to our users is that there will be no special licenses necessary to activate the multi-threaded mode. That is just something you can set in your preferences. And running multi-threaded will consume only one license feature of whatever is needed to perform that calculation. So again, in terms of license usage, it is very conservative. MedChem Designer, this this is an application that exists as a standalone free-for-all. We literally have thousands of customers per year, of people per year who actually download it and install it. It also exists within ADMET Predictor, and actually we provide a license to it for everyone who licenses ADMET Predictor. It can display up to 100 compounds, and you can also compute properties and analyze properties from that interface. It's also the interface that we use to display metabolites, trees, and again, depending on what modules you license, then you have a different set of properties that you can compute from the MedChem Designer interface. And we keep expanding the display features in that part of the software, that now you can look at PK microstates, atomic properties, log-D, solubility, etc. Even the HTPK parameters you can now look at in the MedChem Designer interface. So that's pretty nifty in terms of command line. Again, I think Michael will show how you can run the software from the command line. You can the output, of course, can be read into other programs, and then you have a large number of options in terms of setting up your calculation, in terms of what you want, in terms of output format, in terms of results, in terms of setup for controlling your pH, specific output for workflows, out of scope prediction flags, etc. So you have many different ways that you can control your command line runs. Okay, and just a quick snapshot of what a workflow looks like. So this is a quick example of a NIME workflow where you would basically read an input file and perform some batch calculations in ADMET Predictor, then direct the results to an ADMET Predictor output file, potentially an error log file if there were such problems, and also output to an interactive table that can be analyzed within the NIME environment. And you have the then corresponding panels here that are you can introduce your setup parameters into before you go. So that is a quick again introduction before Michael gets into the live demo. Hopefully give you a pretty good overview of the different ways in which you can access the software functionally, and from also some of the details having to do with licensing. And if you have any questions, I think we have set some time at the end of the webinar to address these questions. Thank you for your time.
Thank you, Eric. That's good stuff. All right, we've got a second quick poll. Are you currently using ADMET Predictor? And if so, in which setup? We'll give you a few seconds to go ahead and answer that. All right, we're going to go ahead and show the poll. We've got some network setups, standalone, and currently not using. So stay tuned, continue on with the webinar. Michael Lawless next, who has worked as a computational chemist since 1991, will be joining us next. Dr. Lawless joined Simulations Plus in 2011 and currently holds the position of Senior Principal Scientist. His interests include using machine learning techniques to predict physiochemical and metabolic properties that are used as input parameters in physiologically based pharmacokinetic simulations. Michael, take it away.
No problem there. Okay, thank you everyone for attending, and thank you, Arlene. So I'll demonstrate license check-in and check-out of ADMET Predictor and the tools that are available in viewer mode. I'll then show the tools that are available in MedChem Designer that only use the MD ADMET Predictor license feature. Next, I'll show how ADMET Predictor works on the command line. And finally, I'll demonstrate how to configure our KNIME node and a short example for that. So as you see, I've opened up ADMET Predictor and opened up a file. And then I'll just go to the settings button here and go into the mode tab that Eric showed on one of his slides. So this allows you to convert the application to viewer mode. We can view license status, and again, in the next version, we'll be able to click on this and see who's using a particular license. These top 8 categories here are for ADMET Predictor, so ADMET Predictor _. The first 2 are free licenses, so the chemistry, and you also get a features that pertains to the descriptors, and then we have the 6 modules that are licensed here. So I've got a 3-user license, and as you can see, all the modules are available and checked in. And then I'll also talk about this MD ADMET Predictor license later. I'm currently using, or I installed the standalone version, so this convert application to viewer mode after 1 hour of inactivity is not highlighted, so it's grayed out, but if I had installed the network version, then this would be available. You can also choose to use the viewer mode when you start out. So first I'll demonstrate the chemistry options, or the options available under the chemistry mode. And when you read in a license, by default, it applies this, so removes fragment when opening files. And the default is to remove common and smallest fragments. Occasionally I'll change it to do not remove fragments if I'm working on a new data set and I'm not sure how the compounds are, what the compounds are. For example, metal atom or organometallics can sometimes be represented as the metal ion and then a dot and the ligand that's attached to it. And if you read that in, it's going to remove the heavy metal, and you'll be working with the not correct representation of the molecule. So sometimes I use that. Remove common fragments looks at a list of common excipients used in drug formulation. And so we have a list of those that it will first remove. And the reason we do that is because sometimes the spectator molecule is larger than the API. And so in that case, removing the smallest fragment would remove the API and you'd be left with the spectator atom. So that's the first thing we do. Then it removes smallest fragments if it hadn't removed all of those. And so in this case, if it does remove any fragments, it will show a picture of the previous structure. So this is the structure actually in the file with the sodium counter ion, and then it will list the AP fragments that are associated with the, or that were removed from the molecule there. And if there's more, it would also move those. So I'm just going to pin those columns, and that will move them over to the left of the broad line, this bold line. And then when I change from various tabs, these will always be displayed there. So the next thing I want to do is go to the chemistry menu, and I'm going to neutralize the molecules. So when I do this, what it does is it takes any compound that has a charge on it or any atom, and if it can add a hydrogen to neutralize that, then it will do so. So for example, it neutralized the carboxylic acid here. Here it took the piperidine nitrogen and deprotonated it to give it the neutral form. And anytime you make a change in the structure, it updates the previous structure column. And you can double click on that and it'll transfer those molecules to the MedChem Designer, and then you can track the changes. So this is the original structure, PS1, that was read into from the file. This is the where it stripped the salts, and then the final structure is obviously what's in ADMET Predictor. The next thing I want to do is go here and standardize tautomers. Now, the reason we include the chemistry module for free is because we think everybody needs to standardize their compounds and get them in kind of a standard format and then predict the properties. Now, for these compounds where it's just a simple addition or subtraction of a hydrogen, if we use this form to calculate properties, it'll give the same results. So that's a simple example there. But if we look at this tautomer that was generated, and I'm going to move this to the top of the row just to see it a little bit highlighted. This tautomer will actually give slightly different predictions than this one. So that's why we emphasize standardizing the tautomers here. Interestingly enough, when you go to the wiki page for cimetidine, you'll see this image shown. But if you go down and you click on the SMILE string and then copy it over, you get this tautomer, which is the incorrect non-preferred tautomer. This nitrile is electron withdrawing and substantially reduces the pKa of this guanidinyl group. So it's important to have the right representation of that for the fraction absorbed in the pKa. So now I'll just go ahead and quickly compute ADMET properties. So you can see the star plots that Eric showed on his slide. And then let's go into under the help menu and view the license status. So you see that the AP chemistry license has been checked out, metabolism's been checked out, phys chem bio, and AP toxicity module. And this is just because we neutralized and standardized the compounds, and then we calculated properties. Now, if we convert to user mode, that checks in the licenses and makes them available for other users to use. And so if we look at some of the icons now that are available, the first one, these are self-explanatory: create a new spreadsheet, open a file, save a file. We still have undo and redo available. And then we have 3 icons with binoculars. So I'm going to click on this first one. This search for attributes in text fields or integer fields. So one thing I'll use this for is if I calculate properties and some of those properties are out of scope for certain models, there'll be a corresponding column called OOS, out of scope. And for any out of scope prediction, there'll be a 1 in that field. So maybe I'll search for a 1 in an out of scope field to quickly identify any predictions that were out of scope for that model. In this example, I'm just going to search for PEF in the ADMET code list. So I type in the string and then the attribute I'd like to search or the column I would like to search. We can do a case sensitive or insensitive search here. We can allow a partial match. So there's going to be other options in the ADMET code or other properties there. So we need to just do a partial match. We can also just search for selected in what's selected in the spreadsheet. And then we can also not deselect any items. So I use this, for example, if I'm looking for identifiers or molecule names. Let's say I want to look for 3 molecules with different names. I'll search for the first one, then click this on, search for the second one, and it'll add it to the selection. So when I click OK here, it highlights 3 rows, and that's described down here in the lower right-hand corner that you may not be able to see, but those 3 rows were selected. And then again, I'll move these to the top, and then I'll go into the risk category here, and you see under ADMET risk, PEF is matched in all 3 of these compounds. Next, I'll use the substructure query dialog box here. So this, we can actually type in a smart string. We could also type in a numeric query. I'm going to use MedChem Designer to sketch in a query. So when I click on that button, it opens up MedChem Designer. And then what I'm going to search for is a 6-membered ring that contains a nitrogen here. And then I'm going to specify a Marcouche atom here. So I'm going to say carbon, nitrogen, or oxygen, then click OK. It displays the atoms that I wish to search for, and then brings that back in the dialog box. Then I'll click OK here, and again, it highlights the molecules and shows them in red. Again, I'll move this to the top and then convert to the tile mode so that you can see these all at once right across here. So we have 4 compounds containing a pyridine ring and then 1 containing morpholine ring. And then we can also use this to build a query. So I'm going to use the query wizard here, and I'm going to do a numeric search. I'm going to search for compounds whose aqueous solubility. So I double click on the S plus SW field here, and it moves it over into the query. So I'm building a query. The next thing I'm going to do is say I want to find things that are less than 0.01 milligrams per milliliters. That's the predicted aqueous solubility. And this is kind of the upper cutoff for flagging things as low solubility in the absorption risk. So then I click OK, it transfers it to this dialog box, and I can change this. So I could edit this, maybe make it 0.05. I could also edit greater than or equal to, or maybe even change that field there. And again, we have similar options in as the other dialog box. So I click OK, and it's highlighted these two molecules. I'm going to move them to the top again using the Control T, which is the shortcut. So it moves it up here to the top. And then I'm going to switch to the PhysChem tab, and then illustrate this last option, which is find a column. So if you have to search for a certain column, you can type it in here and then click OK. And it moves that column or shifts this scroll bar here so that that column appears just right of the pin column there. And you can see that these two are close to my, or have below 0.01. And this would indicate low solubility, and maybe the fraction absorbed would be solubility limited. The next icon I'd like to talk about is the Add Charts. So clicking on that gives you the ability to add another chart. By default, we have a histogram chart and a scatter plot already shown. If you want to overwrite that, you can highlight this to overwrite it. But if you just want to add a new 2D scatter plot, you would just click this and OK, and it would add a second one. And that's nice for making two plots and comparing them to each other. I'm just going to use an example of a bar plot and then click OK. So it adds a new chart here, and I can undock that and then click here on the XYZ axis, and I'm going to plot aqueous water solubility and log P in this bar chart. And then typically what I'll do once I make a plot is I'll just apply that. And so that updates the plot. And then I could, if that's not really what I wanted to see, I could change these. I could set a minimum, maximum, and I could use a log for this one. So all the other ones have different options. So just click OK on that. If I click on a bar, it brings up the compound attributes. So it shows the structure and then all the attributes associated with it. If it's something like a histogram where there's more than one molecule associated with a bar, then it would bring all three of those up. We could use these tools to transfer or to look at each molecule individually. And then we could also show this in the spreadsheet. If I hold down the Shift key, it will highlight that row corresponding to that bar. If I hold the Control button, it will add additional selections to that compound. And then if I double click, it redocks it in here. So the other option I want to show is the 3D scatter plot. Again, just click OK. It builds the model down here. And in this case, this is a little different controller. This is controlled by a minor 3D tool. And we can rotate the graph with holding down the right mouse button. We can make it larger or smaller using the scroll bar on my mouse. You can click a compound to show its properties there. And then again, we'll just double click there to remove it. And then as far as the control options here, one thing you can do is if you hold your left mouse button and drag over a point, it will highlight it. You can hold your Control key to highlight additional atoms there, or excuse me, points on the graph. And then we can push this button to update the spreadsheet for these 4 points. So it'll take these 4 points, highlight them in the spreadsheet. We can also highlight individual rows in the spreadsheet and then transfer that over to the plot. The next tool is the heat map. Typically what I'll do is I'll switch to the All tab so that all of the properties are displayed. And when I go to the heat map, all of them will be listed on this dialog box. Otherwise, it's just the properties that you're viewing at the time, depending on whatever tab you're in. By default, the cells are colored red, yellow, green. So red is lowest, yellow medium, and green highest. I click OK, and it transforms those colors. And then if I, let's see, what did I do wrong? Check all. Okay, so that's colored them, and you see the red is the lowest molecular weight here, and then I can change that direction to descending by clicking on that if I want green to show up as the lowest. And then typically then I would save this as an XTK file. So the XTK format preserves all the coloring, all the properties, etc. So typically, you know, I continually save as an XTK, and then when I open it up, I'm pretty much back to where I started. Another option available is the structure sensitivity tool, and this was added in ADMET Predictor 9.5. So I'll click OK on that. We can select a model. So I'm going to just demonstrate with S-log-P. So what we did here is we took several thousand compounds. We generated predictions, in this example, log P, and then we calculated extended fingerprints, extended connectivity fingerprints for this, and used created a PLS QSAR model for that particular property. And then when you apply that model to a molecule, it's going to highlight the atoms that are responsible for either increasing or decreasing that particular property. So if we look at the most hydrophilic compound in this data set, it's highlighted the carboxylic acid and this amide, this lactam as making a low decreasing of log P. If we look at a hydrophobic compound like this one, it's highlighted the CF3 group and this ring, indicating that those also would be increased here. You can also use this to view queries yourself, so you can create your own queries. We've got a couple queries such as tox alerts that are also available in there. Okay, so that's the demonstration for ADMET Predictor. What I'm going to do is transfer some compounds into MedChem Designer. So anything I highlight in the spreadsheet will be transferred to MedChem Designer. If I have a blank spreadsheet, I can just click that button and then sketch in my molecules and transfer them back to MedChem Designer. So if we just want to calculate properties, so let's say someone had checked out all the licenses for ADMET Predictor, you could open your file, you know, an SD file maybe, bring them into MedChem Designer, and then click on the Add Me button, and it will compute properties for all of the compounds and display them down in this table. You can customize what properties you want to see under the Change Settings dialog box. So for example, if we want to add modeling descriptors, we could, and then this would control the pKa here. So just recalculate, and as you see, that's very quick. And it only checks out this MD ADMET Predictor license. So the AP, PCB, metabolism, et cetera, are not checked out when you perform calculations in MedChem Designer. And of course, that's a really nice advantage. You would see the properties that I just calculated at the bottom of this tool. You can right click on this button to modify the property display order. So let's say I wanted to focus more on water solubility. I could take that property, move it to the top of the list, and then it would appear as the top row here. So that's very nice. We can also export this spreadsheet to Excel. And then, so let's go ahead and just export it to Excel, put it on my desktop, click Save. And then if we open up Excel and open that same one that was saved, so this is sketch.xll. So it generates the structure image or saves the picture. Then we have all the properties. So the PhysChem properties come first, metabolism, and then finally toxicity. and then at the end we would have all the descriptor values on that. Okay, we can also select a single structure and generate metabolites. By default, it generates metabolites for CYP and AOX. So I'll click that. It opens this up in a new window. So see, I've got not only the original window, but the window with the metabolites. I can switch back to the original one for those metabolites, and then we can generate maybe UGT metabolites for that compound. So it'll put the glucuronate dated compound and display that. We also have structure sensitivity under here. You can generate a PK profile and display that in different graphs associated with that tool also. Okay, we can also calculate fraction absorbed, which will bring up this dialog box, so we can calculate predict fraction absorbed, oral bioavailability, and other values in here. So I'll just go ahead and run that quickly, and then scroll down to the bottom, and that's where these properties. So we get fraction absorbed, oral bioavailability, Cmax, Tmax, AUC, and the mechanistic volume of distribution here. Another nice feature is the ability to put up a CP time curve. So with the CP time curve, we can actually do additional doses. So I'm going to do a 1 milligram, 10 milligram, and 100 milligram dose, and then just click run for this compound, and it brings up the 3 curves: 1 milligram, 10 milligram, 100 milligram dose, and then also displays the PK properties for the 1 milligram dose. If we want to change that to the 10 milligram, we would click on the legend here, or 100 milligram, check on that license also. Okay, so now let's go and view a few of the tools available from the command line. So for the command line, you can use a DOS prompt. I'm using an Ubuntu Linux window here that you can install with Windows 10. So this is part of the operating system essentially. And then I've used Sigwind in the past. I typically, I have my ADMET Predictor command aliased, so I could use AP95, and it points to the ADMET Predictor executable in the program files directory. If we use the -H option, it will list the various options for the command. So this first one is required, the -T, to tell it what type of input file you're dealing with. If you just type AP95 on the command line, it actually starts up the GUI interface. So that's why we need these options here. And then this allows you to specify specific modules in your output files as physical, chemical, and biopharmaceutical, metabolism, toxicity, and then the HTPK values here. I'm going to demonstrate a little of the different workflows that can be produced. So physical chemist, cheminformatic, computational chemist, and medicinal chemist. And this outputs the results in an ADME 2D.SDF. So it takes whatever the input file is and appends this to the end of it to make kind of a unique file. You can also specify the Flexera licensing options on the command line. And this is helpful for certain setups of ADMET Predictor on using Pipeline Pilot. So if I just use a simple example here where I'm just using a single file and I just want to calculate properties, I would specify -T in that input file. It loads the predictive models and then processes each one sequentially. And there's a file called, produces a .dat file, which is just a comma-separated list of the properties. And so you can read that into Excel, for example, here and see all the properties. Okay, the next example is using the MedChem, medicinal chemistry workflow output. So again, I'm going to use a -T here, and then a workflow medicinal chemist. And my example is this SMILES file. So here it creates an SD file, and then I can display that SD file in ADMET Predictor again. So this has 4 compounds, and they have various ionization states. And so one of the key things I like to point to here is this, it displays the pK properties. So things like the highest basic pK, the lowest acidic pKa, list all the pKs in a particular column, and then also tells you what the predominant charge state is at pH 7.4. So this is zwitterionic, positively charged, and negatively charged compounds here. So then the next flow is a physical chemist. And let's see what comes out of that. Here we're only doing 1 compound, and so we'll display the results of that 1 compound. So for a physical chemist, they might be interested in all the different ionization states here. So I use cetirizine as my example, and what we're outputting here is essentially the microstates display. So we get the overall charge of this is a -1, where there are no the ionizable groups protonated. It's 100% in its microstate. Then down below here, we get the 2 microstates that are neutral. Now note for cetirizine, they're actually zwitterionic. Let me make that a little bit bigger. So in this case, in both cases, the carboxylic acid is deprotonated, and then one or the other nitrogens in the pyrazine ring would be protonated. And so really what we're doing is we're displaying the pK of microstates just as an SDF file. So you can export all these on the command line. And then finally, I just want to show what the computational chemistry option is for the workflow here. So I'm just processing 1 compound here. And what this will output is that particular compound in the prevalent microstates at pH 7.4. So for cetirizine, the most prevalent one is the zwitterionic, with the nitrogen furthest away from the phenyl rings protonated. Then the other 2 in lesser quantities are the negatively 1 charged, and then neutral one where the other nitrogen is protonated. So you might want to pipe these into a 3D generator, and it will generate the structure in 3D with the proper atoms protonated, and then you could use that in a docking exercise. So we're kind of running up against the time, so I'm going to skip the NIME example and then just turn it back over to Arlene to finish up.